All right, another great video from me. Here we go. Chapter 2.2. It's composite functions. All right, so let's look at the definition of a composite function. We are combining two functions, f of x and g of x, to create a third function. So what we have to do is we have to be careful with the domain and range whenever we deal with a composite functions. There might be some restrictions from one function, and when we put it into the other, we have to limit the domain and or range of that third function. We might see this notation, f of g of x. Now, I drew this little arrow because this reminds us that we're putting g into f. So we see this notation, f of g of x. Here, g of x is inside the f of x. So we take that whole function and we drop it right inside f. Here we have g of f of x, and so here we have f of x that's inside the g of x. Okay, so just some notation there for you. And let's look at an example. Example number 1. It says, find a composite function if f of x is equal to 3x and g of x is equal to 2x minus 6. A, f of g of x. So again, we are putting g into f. So here's f, and we're going to put this whole function right here into that x. So 3 times 2x minus 6. We distribute the 3, we get 6x minus 18. Letter B. It says find g of f of x. Well, here again, we're putting now f into g. So I'm putting this function, 3x, inside that x right there for that little x. So we'll take that whole piece and put it here. So you'll see 2 times 3x minus 6. So in this case, when I multiply that out, I get 6x minus 6. All right, let's look at another example. And this time it says, find a composite function, then evaluate at a given x value. If f of x is equal to x squared plus 1, and g of x is equal to x minus 2, find g or f of g of x. F of g. So again, g of x is sitting inside, so g of x is going to be placed right here for that x. So here we go. Here's what was the x there, squared. So we put all x minus 2 in, square it, plus 1. There's the plus 1. Now because this is squared, I'm going to have to expand this out. You know your binomials by now, and this is a binomial square. So we have x squared minus 4x plus 4, and then this outside plus 1 stays in. Simplifying, we get x squared minus 4x plus 5. Now, part B says, find f of g of 2. Well, this is, remember again, similar notation. We go back, rewind the video, and you'll see that these two are same notations. All we did is they said, hey, find it when x is 2. All right? We'll take what we have, x squared minus 4x plus 5. We'll put in a 2. That's 2 squared. Minus 4 times 2 plus 5. We get 4 minus 8 plus 5. 4 minus 8 is negative 4. Negative 4 plus 5 is 1. So we've evaluated. All right. Now, last one says, find the domain of the composite function. We've got f of x is x squared minus 4. And we also have g of x is the square root of x. So what you want to do first is find the domain for each one, and then see how they're restricted and how we can write the domain for the final function. X squared minus 4. Domain simply is x is an element of all real numbers. The range, however, on this goes from negative 4 to infinity. All right? Quadratic function that's been moved down 4 units. G of x is a root function. We know we can't have any negatives under the radical, so our x is limited to 0 and to infinity. All right, so we can include 0 though. Our y value then, since this is a positive, our y value will also be limited to including 0 and greater or to infinity, and not including infinity. So now, let's put it together. They've asked us to find f of g of x. So again, we're putting g into f. There we put, here's g into the x squared minus 4. Now again, because this domain right here was limited to 0, right? Because this domain was limited to 0, then my new domain has to be limited to 0. And if we do that, then if we put in, that means here, when we simplify the function, square root of x squared is going to be just x, and then minus 4 comes along. Now normally this is a linear function. You might say, well, linear functions, all x's are available. But because it was originally a composite, we have to limit it to 0 to infinity. If I put a 0 here, then that means that the lowest possible y value will be negative 4. So my y's then, y is an element of negative 4 inclusive to infinity. All right? You might have to rewind that one a couple times and listen to it. I know that's kind of an interesting topic, the domain of a composite function. Thanks. Have a great day.